Hello everyone, my name is Praveen Kumar. I hope I'm loud and clear. Am I audible? Could you guys confirm in the chat window? Okay, Sunil says yes. Hello Sunil. Can anyone else also confirm? Okay, Santana Lakshmi also says yes. Okay, Deepak also says yes. All right, all right. So today we have less count, but let's start the session with the same zeal and enthusiasm. All right. And the ones who do not know me, my name is Praveen Kumar. I'm the founder of towardsmachinelearning.org, and we have Gavit with us, who has given the live session already on research papers and journals. If you have not attended his live session on research papers and journals, then please go back and refer the recorded session. Is already available on the Facebook page. I'll share you the Facebook page link as well, but you can simply search towards machine learning on the Facebook, and you will be able to reach to the Facebook page. So today he's with us to present on the boosting algorithms. I'm pretty sure if you are into data science field, then you must be knowing about the different boosting algorithms and the importance of the boosting algorithms when it comes to the sophisticated data set. So without further ado, let me hand it over to Garvit. Galvit, please take the session forward from here. And I request all the participants to mark your attendance on the links that have been shared. If you are on the LinkedIn, please, mark your attendance on the LinkedIn post. Link is already provided. If you do not have LinkedIn, then please mark it on the Instagram or the Facebook, whichever profile you have. If you do not have either of these or neither of these, sorry, then please do create one. It's high time you are into data science, and obviously LinkedIn is it comes a lot handy. Thank you so much. Over to you, Garvit.
Okay, sir. Thank you, sir. I guess I am audible to everyone. Please write in the chat box so that I can start. Anyone can write. Okay. 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 So a very good evening to everyone. I am Garvichuk and I will be delivering today's session on boosting algorithms in machine learning. So we will be dealing a variety of things about the boosting algorithms in this session. Okay, we will be seeing ensemble learning, ensemble methods. We will be moving ahead towards what is boosting, also towards what are the different algorithms we use in different boosting algorithms that we use in machine learning. Okay, so we are going to see the practical applications, its advantages, disadvantages, and a lot many things about boosting algorithms. So let's start our today's session with ensemble learning. Okay, as boosting algorithm is a part of ensemble learning only, so we will start with ensemble learning. So what is ensemble learning? Basically, ensemble learning is a type of learning which combine multiple weak learners to form one strong learner. Okay, so let me tell you this with the help of an example. Suppose if you ask a complex question to thousands of random people and then you just aggregate the answer, in many cases you will find that this aggregated answer is the better than any expert's answer. Okay, so let me tell you this with the help of one use case, that is everyone in India or anywhere outside India, we know what is voting. Okay, we know about what is voting. Okay, so let me tell you that suppose we have a group of suppose you can say 30-40 people. Okay, we have one club of 30-40 people. Now we have to choose the president of the club. We have three candidates. Okay, and now the voting happens. Everyone casts the votes and one who get the majority of votes wins the election and will be the president of that club. So keeping this scenario in mind, let's apply this in ensemble learning. Okay, ensemble learning basically deals with the wisdom of the crowd. Okay, in this group, every person casts his or her vote in the favor of one candidate. So each vote is a weak learner. You can treat each vote as a weak learner. Similar way, ensemble learning combines these multiple weak learners to form one strong learner. That is, in our case, is the president of that club. Okay. So when compared with this single model, you can take any single modeling, maybe it is logistic regression, maybe it is decision trees or any other model. So this type of learning builds with improved efficiency and accuracy. Okay. So this is basically the idea behind ensemble learning. So as you can see on your screen, we have the diverse predictors. Okay, these are different models. Maybe one is decision tree, one is logistic regression, one is SVM. Like this, there are different models. Let me show you this with the help of a pen. So this is the first model. This is the second model. Likewise, these are, we have four models. Okay, we have passed a new instance to all these models. Okay, so now this model gives the output as 1. The second model gives the output as 1. The third model gives the output as 2. And then the fourth model also gives the output as 1. So what's the ensemble prediction? As I told you, ensemble combines multiple weak learners to form one strong learner. So you can see that in voting, one wins the election. As you can see, one wins the election. So now one is the ensemble prediction. Okay, so in this way the ensemble learning performs. Now we have different parts of ensemble methods. We have pegging, we have boosting, we have stacking. Okay, ensemble methods are just the methods which apply this ensemble learning. Okay, so bagging, as you all know, in bagging we have random forests. Okay, how they work parallelly. Second, we have boosting, they work sequentially. And another, we have stacking. Okay, stacking, it is basically a different paradigm. The point of stacking is to explore a space of different models for the same problem. Okay, the criteria of this session is basically on boosting. Okay, so before moving directly to boosting, let me tell you the difference between the bagging and boosting. As you can see in this slide, uh, in bagging we have a parallel approach for the weak learners, and in boosting we have the sequential approach. Okay, bagging, where weak learners are produced parallelly, performance is increased by training the weak learners parallelly on the bootstrap dataset. As you can see that all the weak learners, they are produced parallelly, and in boosting the weak learners, they are produced sequentially during the training phase. Okay, the performance of the model is improved by assigning higher weights to the previously incorrectly classified samples. Okay, it will be more clear, you will be more clear about boosting as you move ahead. So boosting, it refers to any ensemble method that combine multiple weak learners to form one strong learner. The general idea behind most of the boosting methods is to train the predictors sequentially. Okay, as we have seen in the previous slide, we are we are training our weak learners sequentially in sequential approach. So each trying to correct its predecessor. Okay, we had different types of boosting algorithms like ADA boost, the gradient boost. We will discuss about each of them in the upcoming slides. So boosting is they are primarily used in machine learning for reducing the bias and variance. Okay, they are very much good in improving the bias and variance. I have this figure with you. You can see that here we combine the outputs of the multiple weak learners to form a one strong learner. Okay, it is very clear from this diagram. We have the output of the first weak learner, then we have the output of the second, the third, and up till n weak learners we have the outputs, and now we are combining them to form one strong learner. Okay, it is used to increase the accuracy of the model. Okay, as the incorrectly classified samples, they are being giving more weightage, or they are we are continuously training on dead samples, So your accuracy will definitely improve at the end. This is the working of the boosting algorithms. Okay, as you can see on your screen that in the model 1, the weakness of the model 1 is passed to the weakness of is passed to the model 2, and the weakness of the model 2 is passed to the another model, and up till n models the weaknesses are passed. So every time we are dealing with the weaknesses of the previous model. So as you can see that at last the accuracy will definitely improve, because the, at each and every time it each and every model, the the weaknesses are being handled. Okay, so this is an example for boosting. Now you can see this is an example where we have to classify a dog and a cat. Okay, so these are some of the features that we have for our instance. Like say we have the image that has pointy ears, the image has cat shaped eyes, the image has bigger limbs. These all are the features of a particular instance. Okay, so now if we were to classify an image based on individual rule, then the prediction will be flawed. As you can see that image has pointy ears, it is really very uh, bad way to predict, or only on the basis of this one feature that the image has pointy ears. We can say that this is a cat. Okay, but some dogs may also have pointy ears, some cats may also have bigger limbs. Okay, so when we combine all these features together and then the voting happens, we can easily say that yes, this particular instance is a cat. Okay, so each of these rules, they individually they are called weak learners, because these rules are not strong enough to make predictions all alone. Okay, so this is how boosting helps. Now we have three boosting algorithms which we will discuss in this session. We have ADA boost, we have gradient boost with us, and also we have extreme gradient boosting. So before moving towards these boosting algorithms one by one, I would like to ask everyone that is all the things just now, like the ensemble learning, the ensemble methods, and all about boosting is clear to you all? Please reply in the chat box. Okay. Yes, Anantha Lakshmi says yes. Please, everyone, do comment. Sunil. Okay. So I guess no one has any doubts, and it's clear to everyone the basic idea of boosting and the ensemble learning and different parts of ensemble methods. Okay. So now let us move towards our first boosting algorithm, that is ADA boost. Also, it is a short for adaptive boosting. Okay. L- Let me tell you that the ADA boost is the first stepping stone in the world of boosting algorithms. Okay, it is the first ever boosting algorithms which was invented yet. Okay, so ADA boost, it works on a principle that one way for a new predictor to correct its predecessor is to pay a bit more attention to the training instances that the predecessor has incorrectly classified. Okay, as I told you, the whole boosting is based on the idea that uh, the weakness of the first model is passed to the second model, and then the weakness of the second passed to third and up till n models. So like this way, uh, following this approach only, ADA boost, what it does, it basically assigns more weights to the incorrectly classified samples and give less weights to the correctly classified samples. Okay, this results in a new predictor focusing more and more on the hard cases. So this technique is used by ADA boost. Okay, so for example, to build an ADA boost classifier, a first base classifier such as a decision tree which is trained and is used to make predictions on the training set. the relative weight of the misclassified samples, they are increased and passed to the second classifier, second weak learner. Okay, these updated weights, they are passed to second. Then the misclassified weights of the second model, they are passed to the third model. Like this way AdaBoost works. Okay, so now before starting the working of the AdaBoost, I would like you all to understand about what is stump. Okay, you all know about decision trees, how decision trees are made. We can build decision trees up till any level, up to fourth level, 8 level, 10 level, up till any level we can make decision trees. But in AdaBoost, what it does, uh, it makes this stump with the help of a single node and two leaves. Okay, this is basically they are the weak learners in the AdaBoost. Okay, the weak learners which I was talking about in AdaBoost algorithm, this stump is only that weak learner. Okay, so the one thing to focus on is the order of these stumps. They are very important at Dabus, because as I told you that we are passing the error of the first stump to the second stump, and then the error of the second stump is passed to the third stump. So uh, the error of the first stump influences how the other stump is made. So that's why the order is very important. You can't shuffle among the stumps. You have to keep a particular order of these stumps. Okay, so now let's move towards the working of the AdaBoost. So I have taken this example about AdaBoost. Okay, we have five rows. Okay, we have five records with us, and uh, uh, we have the outputs. As you can see, yes, yes, no, no, yes. These are the outputs of these instances. Okay, so at the very first step, the AdaBoost, it tries to assign a sample weight to all these features. Okay, let me tell you that this sample weight, uh, it is same for all the instances in the very first step. Okay, as you can see, we have the formulators. We can easily say weight is equals to 1 upon n, where n is the number of the samples. So in the sample weight, uh, we can see that the 1 by 5, 1 by 5, it is the sample weight for all the instances. It is same for all the instances. Okay, so this is the very first step. Okay, now in the next step, the AdaBoost, it will try to create the base learners based on the features we have. Like as you can see, we have three features. We have feature 1, feature 2, and feature 3 with us. So it will create stumps based on the first feature, the second feature, and the third feature. Okay, it will create the same number of stumps as the number of features. So now, out of these three models, like these three features, these three features we have taken, and we have built three stumps. So among them, the algorithm selects the one. Okay, for selecting a base learner, there are two properties. As you can see that we have Guinea impurity and we have entropy, as you learnt about in decision trees. So we can easily calculate these properties. These figures we can easily calculate. So after calculating the Guinea entropy, the stump that has the least value, for this Guinea impurity or entropy, we will select that as our first base learner. Okay, so in the figure, as you can see, all the three stumps can be made with the three features. The number below the leaves, these numbers, this 2120 3002, these are the numbers which represents the correctly and the incorrectly classified records. So by using these records, the Gini or entropy index is calculated. The stump that has the least, as I told you, that the stump that has the least Gini impurity or entropy index, they will be treated as a first base learner. Okay. So now, as we have assumed that we have taken the stump 1, okay, we assume that the entropy index for the stump 1 is least and we have selected stump 1. So now, on as we have taken this stump, this feature has incorrectly classified the second record. Okay, I am marked that in red. Okay, as you can see, this record is being incorrectly classified by the first stump. So now, in the next step, what we will be doing is we will be calculating the total error. Okay, total error. The formula for total error is the number of samples classified as wrong upon total number of samples. So as you can see in this table, we have 5 records, and out of 5 records, this row number 2 is classified incorrectly. So our total error will become 1 by 5 in our case. Okay, so now in the step 4, what we will be doing, we will be calculating the performance of the stump based on this calculated total error. Okay, the performance of the stump will be calculated with the help of the formula 1 by 2 log into log to the base of e into 1 minus total error upon total error. Okay, so like this way we can calculate the performance of the stump. Okay, so now you will be thinking that why we are calculating this total error, why we are calculating this performance of the stump. Okay, so if anyone has any idea about why we are calculating this total error or this performance of the stump, they can reply in the chat box. If anyone has any idea why we are doing like this, why we are calculating the total error, why we are calculating the performance of the stump, the basic idea I have already given you in the introduction of ADA Boost. If anyone has any idea, they can reply in the chat box. To know the misclassified instances. Okay, to get a result fast. Um, no, Gohar, that's incorrect. Sanand Lakshmi is somewhere correct. Anyone else want to try? Okay, so let me tell you. The, okay, someone else is also for accuracy. Yes, nearly close. But the answer is that we must update. We have, as I told you, that we have to increase the weight for the misclassified samples, and we have to decrease the weights for the correctly classified samples. So that's the main reason behind why we are calculating this total error and the performance of the stump. Okay, because as you know that in boosting only the wrong records on the unclassified records, they got more preference than the correctly classified records. Okay, we are dealing more with the misclassified records, so thus only the wrong records from the decision tree or the stump, they are passed to the another stump. Okay, so we must increase the weight of the wrongly classified records and decrease the weight for the correctly classified records. So in the next step you will be seeing. Yes. So in the next step, you will be seeing that we will be updating the weights of these records like this. Okay. As you can see here, what we have done is we have updated the weights of the incorrectly classifieds with the help of a formula weight into e to the power of performance say. The performance say which we have calculated as I told you. Okay, let me show it to you again. See, from here where we have calculated the total error and then we have calculated the performance of the stump. So from here we got the performance say. We will be using this performance say to update the weights of the incorrectly classified samples and for the correctly classified samples. For incorrectly classified samples, we will be multiplying weight into e to the power of performance say, and for correctly classified samples, we will be doing weight into e to the power of minus performance say. So by this, you can see that the updated weights of the correctly classified samples, they will be decreasing, and the incorrectly classified samples, their weight is increasing. Okay, you can see that for the correctly classified samples, we will get zero point 0.1 as the updated weight. After you perform all this calculation, you will get zero point 0.1 in our data set, and for the misclassified sample, we will be getting 0.399. Okay, so one important thing is that after you update these weights, you need to normalize these weights. As you can see in the sample weight, when we add all the weights together, we will get 1 as the total weight. Okay, but when you add all the updated weights together, you will never get 1. Okay, so to solve this issue, what we do is we normalize the weights. For normalizing the weights, what we will do is we just calculate the sum of the updated weights and divide them with uh, 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 we have to divide our updated weights with the total sum of these updated weights. Okay, you calculate the total sum of the updated weights first, and then you have to divide it by the weight of the each instance. Okay, so you will get normalized weights. Okay, this normalization is very important after updating the weights. So now we have calculated all these things. We have calculated the updated weights. We have transformed that in the normalized weights. So now what? Okay, now what Adabus does? So now let me tell you that these now the algorithm, it will run 5 iterations to select different records from the older data set. Okay, in each iteration, the algorithm will take one random value and select the record whose bucket contains that value. Okay, let me explain this with the help of a pen. Okay, as you can see, these are our normalized weights and these are our buckets. So now what data boost will do, it will create the buckets. Okay, 0 to 0.13. Okay, now from 0.13 you add 0.13 and 0.50, you will get 0.63. Okay, so 0.13 to 0.63 is in the bucket of the second record. Then again 0.63 plus 0.13 is 0.76. So now 0.63 and 0.76 is in the bucket of the third record. Okay, so now ada boost will run 5 iterations and to select the different records. Okay, each time it will generate one random value between 0 to 1. Okay, now let's say in the first iteration the ada boost has given us a random value of 0.46, let's say. Okay, 0.46. So which record is being selected among these? Please reply in the chat box. Okay, anyone can reply in the chat box. We have got a random value as 0.46. So it is falling in which bucket? On which record it will target? You can reply in the chat box. Point, got 0.1 to 0.63. Okay, I think you are saying 0.13 to 0.63. I guess. Yes, Deepak Panmani, you are correct. Yes, Anant Lakshmi. Yes, okay, go ahead. Okay, so as we can see in our table, which is behind this, you can see that this second record, this is the only misclassified sample. So now in the first iteration, we have got this record only selected. Now in the second iteration, let's say our random value will give 0.53. Again this record is going to be selected. So as the as there is a huge amount of numbers that lie in this bucket only. So ADA boost will there is a high probability that this wrong record is selected maximum number of times. Okay, this is all what we need to do only. Okay, let me raise it so you can see it clearly. Okay, so there is a high probability that this wrong record it got selected several number of times. Okay, so now ADA boost will run these iterations, build a new data set taking the records which are selected in each iteration. Now, this new data set is a training data for a next week learner. Okay, it will be passing this data set to the next week learner. Okay, so as you can see that this misclassified record is targeted the maximum number of times. So most of the times, this record is only selected in that data set. So, like this way, the ADA boost will be focusing more on the misclassified samples, and at last, you will see that the accuracy of the algorithm has improved a lot. Okay, I would request you to please keep your mics off. If anyone has had unmute themselves by mistake, please. Okay, so this is basically how the ADA boost works. Okay, so now how the algorithm it decides the output for the test data. This all we have done for the training data. We have trained the algorithm. Now when you pass the test data, how ADA boost works with that test data. Okay, so this is the answer. Okay, when you pass the test data to your ADA boost algorithm which you have trained, okay, while passing your records it will be passing through all the stumps. Okay, let's say if you have built three stumps, it will be one by one passing through all of these three stumps. And while passing through the first stump, let's say it gives the output as 1. While passing through the second stump gives the output as 1, and while passing to the third stump it gives the output as 0. Again, wisdom of crowd happens. Okay, majority of votes. The uh, the uh, the, uh, the sample which is getting the majority of the votes, okay, between these stumps, it will be considering that as the final output for the test data. Okay, this is how the output is going to be decided for the test data. Okay, so this is the whole workflow of the ADA boost algorithm. Okay, from step 1 till step 5 we have discussed all these steps. So I think there will be no problem in understanding these steps. Now we move towards the various advantages for the ADA boost. Okay, ADA boost has various advantages. As you can see that we have not tweaked parameters more. Okay, at all we have not tweaked parameters at all in while discussing the working. Okay, so it is easier to use with less need for tweaking parameters, unlike algorithms like svm where you have to set a lot of parameters. Okay, so and the second advantage is that till date there is no concrete proof that ADA boost is prone to overfitting. Okay, there's a reason behind this, because the reason is that the parameters are not jointly optimized. Stage-wise optimization slows down the learning process. As you have seen, we have doing everything stage-wise. Okay, so there is no chance for overfitting. Okay, ADA boost it improves the accuracy of your weak classifiers and makes it flexible. Okay, uh, you will be very flexible while using this as a ADA boost, and even you are getting a very good accuracy. Okay, initially when ADA boost was invented, it was only used for binary classification, but at this stage the ADA Boost has its use cases in text and image classification as well. Okay, I have one example for image classification also in the practical applications for ADA Boost. Okay, now let us see what are the disadvantages of the ADA Boost. Okay, as you know that this boosting technique, it learns progressively. So it is important to ensure that you should have quality data. Okay, let me tell you that Adaboost, it gets affected by the noisy data and the outliers. So if you are using Adaboost, if you decide to use Adaboost, it is highly recommended that you should eliminate all these noise data and the outliers. Okay, and Adaboost, it is proven to be much more slower than the XGBoost. XGBoost is faster among all these boosting algorithms. So XGBoost is the fastest. So Adaboost is basically, it is slower than the XGBoost. These are some of the disadvantages which you have to see about Adaboost. Now, moving towards the practical applications of the Adaboost. Okay, Adaboost uh, uh, is used to solve a variety of real world problems. Okay, such as predicting customer churn and classifying the types of topics customer are talking about. Okay, first I want to ask you that how many of you know about this customer churn? What is customer churn rate? If anyone knows, please reply in the chat box. If you don't know, please type no in the chat box so that I can explain you what is this churn rate. No, okay, okay, Sunil, okay, go ahead. No, sir, okay. How likely they will desubscribe? Okay. Yes, yes, yes. Yes, Monish, you are correct. Customer leaving from organization or service sector. Yes, Deepak, correct. Okay. So those who don't know about the churn rate, let me tell you that the churn rate is also known as the rate of attrition or customer churn. Basically, it is a rate at which customers stop doing business with the entity. Okay, it is commonly expressed at the as the percentage of service subscribers who discontinue their subscription. As we have got one reply in the chat box from Munish, he says how likely they will re-subscribe or customer leaving from the organization. Okay, so it is basically that only, that the percentage of service subscribers who discontinue the subscription within a given time period, it is known as customer churn rate. Okay. So many companies are using Ada Boost in predicting this customer churn. Okay. Second, the algorithm, it is used for solving many classification problems. Given its relative ease of implementation in languages such as R and Python, you will see very easy implementation of the Ada Boost. Okay, in these languages like R and Python. Normally, we use these languages only while dealing with data science problems. Okay, now this is the practical application which I was talking about for image classification. Okay, we have one research paper for detection of pedestrian using patterns of motion and appearance. This research paper was published by Paul Viola, Michael J. Jones, and Daniel Snow on IEEE ICCV, which is the International Conference on Computer Vision. Okay, it is really a amazing research paper. If you have time, it's available online. If you have time, please go through this research paper. Okay, I have even talked about the IEEE journal in my research papers and journals session. Okay, it's a open access journal, so every research paper is available online. You can go there. It's basically a pedestrian detection system which is using image intensity information and motion information with the directors that are trained by using Ada Boost. Okay, so this is basically the practical application of the Ada Boost. Now we will move towards a next boosting algorithm, that is the gradient boost algorithm. Before moving towards gradient boost, if anyone has any doubt, you can ask in the chat box about Ada Boost. If you have no doubt, you can reply no. No doubt, sir. Okay, Sunil. Please, everyone, do write in the chat box. Okay, go her. Okay, I'm waiting. Is everyone write in the chat box? No doubt. Okay, Frederick. Okay. So I guess no one is having any doubt. So let's move towards a next boosting algorithm, that is basically gradient boosting algorithm. So let me tell you that ADA-boost and related algorithms, they were recast in a statistical framework first by Bremen, calling them RCing algorithms. The full form of RCing algorithms is adaptive reweighting and combining algorithms. Okay, Bremen called them ARCing algorithms. And this framework, this ARCing algorithms, they are further developed by Friedman, and he called this as gradient boosting machines. Okay, later on, it is just called gradient boosting or gradient tree boosting. Okay, so this is the basic history behind gradient boosting. So let me tell you that gradient boosting, it relies on the intuition that the best possible next model, when combined with the previous model, minimizes the overall prediction error. Okay, as we combine all the models together, they tend to minimize the overall prediction error at the end. Okay, the key idea is to set the target outcomes for this next model in order to minimize the error. Okay, you will be understanding more about this algorithm as we will discuss its working. Let me tell you that this algorithm, again, it can be used both for classification and regression problems. Okay, so this is the figure for the working of gradient boost. As you can see, we passed a data set to our first model, and then we calculate the residuals for from this model, and we train our next model based on these residuals. Okay, so how you calculate the residuals, what you do, that we will discuss in the working. This is just to give you a basic idea about gradient boosting. Okay, so now before starting the working, i would like I would like you to see uh, these three important things about gradient boost. One is the loss function that needs to be minimized. Second is the weak learner for computing the predictions and forming one strong learner. And at last, we have one additive model that will regularize the loss function. Okay, we will be discussing one by one about all these three things. First, we will talk about the loss function. What is this loss function? Okay, so now, as you know, that we have various loss functions available with us. Okay, for regression, you can use you can use squared error. For classification, you can use logarithmic loss. Okay, uh, so there are various loss functions. Okay, you can choose the loss function according to your problem statement. If you are using regression, you can use squared error or any other loss function. You If you are using classification, my suggestion is to use logarithmic loss, because there is one condition in gradient boosting. Okay, as you can see that in gradient boosting, the loss function, it needs to be differentiable. Okay, we can only use the loss function that is differentiable. Okay, you can even develop your own loss function. You can define your own loss function. There are many standard loss functions that are differentiable, but you can also define your own. But the condition is that there needs to be differentiable. Okay, now the weak learners, the okay, the weak learners, the decision trees, they are normally used as the weak learners. Okay, as you have seen in ADA boost, what we have done, we have made a stump. Okay, stump just with one node and two leaves. Okay, that is the weak learner for ADA boost. In gradient boost, you can build larger trees. Okay, larger trees that can be generally with 4 to 8 levels. Okay, you don't have to make a decision stump, you have to make a whole tree. Okay, now these trees, they need to be constructed in a greedy manner that choose the best split points based on purity scores like Gini, or to minimize the loss. Okay, uh, this is to ensure that the learners, they remain weak. Okay, you don't have to build the whole decision tree algorithm at all. Okay, you should make a trees like that they remain weak, as they are weak learners. So you have to ensure that they remain weak, but still they can be constructed in a greedy manner. Okay, it is common to constrain the weak learners in a specific way, such as you can define maximum number of layers, the nodes, splits, or leaf nodes. These all things you can define while you are building a decision tree for gradient boosting. Okay, now we will discuss about additive model. Okay, uh, uh, these when we will be discussing about the working, at the last step of the working, you will see that we will be combining all these weak learners together in order to make one good prediction. Okay, uh, I think you all are aware about the gradient descent approach. Okay, let me draw its figure with the help of a pen. Let's say we have something like this graph and we have this curve. Okay, it's try to understand, this is a convex curve. Okay, now what we do in gradient descent is that, let's say if we start, this is our global minima, this is our global minima. If we are starting from here, we take small steps in the direction of this global minima. Okay, pardon me for my handwriting. I think you can understand. We are taking these small steps to this global minima. Okay, the similar approach we will be using in gradient boosting algorithm also. We will be calculating the residuals, and and at the end we will be combining the output of all the trees together in order to give a good output. Okay, as you know, in gradient descent, what we do is we have a fixed number of trees, and they are in gradient descent. What we do is we have to reach to this global minima, and once the loss reaches to an acceptable level, or we can see that no longer improvement is taking place, or trading stops there. Okay, the similar approach we are going to follow in gradient tree boosting also. Okay, it will be more clear to you when we will discuss its working. So now let's start about the working, how gradient boost really works. Okay, so at the very first step, what gradient boost does, if we have some data set with us, gradient boost makes its initial prediction. This initial prediction, this is a leaf which is the initial guess for all the weights of the samples. Okay, while doing regression, you can easily take the average of all the values and make it as your first guess, your first prediction. Okay, but in classification, what you can do is you can use log of odds, and then you convert those log of odds in the probability by using the logistic function. This logistic function, if you have learnt about logistic regression, uh, you know what is this logistic function. We have something like this. Okay, this is our probability zero point 0.5. Okay, this is our probability. uh, so this is the all the values that fall above this zero point 0.5. Let's say these are some of the points. These fall apart from this point 0.5 above zero point 0.5 probability. We treat them as the positive instances, and the instances it's got lesser value than zero point 0.5, we treat them as the negative instances. Okay, you have learned about this logistic function in logistic regression. Okay. Okay, Sunil, what's the difference between a boost and the gradient boost? Okay, if you can wait for a while after completing this gradient boost, I have added the differences between the gradient boosting and the ADA boost. Okay, so after completing the gradient boost, you will get it what is the difference. Okay, now let's move ahead. Okay, so this is our initial prediction. Now let's see this example. Okay, in this example we have two features. We have the observed value, that is basically the actual value, then this predicted value 1, which in the previous step we have predicted. Okay, I termed it as y hat 1. Okay, so this is our first predicted value. Now, what gradient boost does, it tries to compute the residuals. How do we compute the residuals? We just have to subtract the predicted value with the observed value. Okay, like you can say we have observed value of y1 and the predicted value is y hat 1. So, while computing the residuals, you have to do y1 minus y hat 1 and you will get your first residual. Okay, now, one thing to remember that sometimes these residuals, they are known as pseudo residuals. Now, why we are saying them as pseudo residuals? If you have idea about linear regression, in that linear regression, we also calculate the residuals. Okay, they are also the difference between the observed and the predicted values. Okay, if I can explain you with the help of a diagram, I can explain you. Okay, when we do linear regression, what we do, like say if we have this line. Okay, this is the line for our linear regression, and some points if we have here, these are some samples. So in linear regression, what we do, we try to subtract these residuals in these points in order to get residuals. Okay, if you remember linear regression, we do this thing. Okay, so uh, that's why we call the residuals present in the gradient boosting as the pseudo residuals. The pseudo is a part of pseudo residual, uh, uh, which is a reminder that we are doing a gradient boost and not linear regression. Okay, so not to confuse between linear regression and gradient boosting. That's why we call these pseudo residuals. Now, moving towards the next step. Okay, now we have, as you can see, we have calculated the residual. Now, what gradient boost does, it will try to construct a decision trees based on the input features and these residuals. Okay, it will try to fit these features according to the output of our first residuals. Okay, the residuals, you know that we are calculated with the help of observed value minus predicted value. Okay, it will be more clear if I show you the next figure. Okay, now you can see that this table, uh, what it has done, it has calculated the first residual, then it tries to fit these features and these residuals in a decision tree. Okay, it will try to fit these. Now when you are fitting these residuals, okay, now when you are fitting these residuals and features together, you will be getting your new predicted value. Okay, you will be getting this new value, and again with this value you can compute the new set of residuals, again subtracting these y hat 2 from y1, you will get your second residual. Okay, Like this gradient boost is focused on building more and more trees and predicting new residuals at each step. Okay, at each iteration, you can say. Okay. uh, uh, Now let me remove this link. So I guess this thing is clear to everyone. Okay. After after building all the trees, calculating the residuals of all the trees, now gradient boost, what it does, it will try to add the output of all these trees together. Okay, as you can see, we as you can see, we have this formula fx equals to h0x. It is the output of a base model. Then we have alpha 1 h1x. I will tell you about what is this alpha. We have alpha 1 h1x, which is the output of a first model, then output of a second model, and similarly up till n we can add the output of all the decision trees together, okay, in order to get one good output. Now what is this alpha? Let me tell you that there is one disadvantage of gradient boost, you can say, or one lacking in gradient boost, that it overfits the data. Okay. So if you give some instances to it, it tries, while training, it tries to overfit your data. So to overcome this issue, we have to multiply this alpha, which is basically the learning rate. Yeah, I have defined this here also. Okay. So to solve this, we normally have to multiply these outputs with the learning rate. This learning rate ranges between 0 to 1. Okay, normally we try to take it as small as possible, because in if you have studied about gradient descent also, you know that if we take a learning rate a bit more high, then instead of converging, your curve goes on diverging itself. Okay. So that's why uh, we have to take this as low. Otherwise it depends on the problem which you are solving or on your data set also, but always try to keep this learning rate as low as possible. It ranges between 0 to 1. Okay. So in regression, what you just give me a minute. Okay. So in regression, what you can do, you can easily add all the trees together. Okay. But in classification, remember, you have done that with the by taking log of odds and then calculating the probability. Okay. So you cannot directly add the outputs all together. Okay. You have to perform some sort of transformation in classification problem while doing gradient boost. Okay. I have added the formula for the transformation also. I will tell you in just a moment. Before that, see this figure. Okay. What it's doing, it's just combining all the trees. Okay. This is how our model at the end will be looking. We have the base learner, this sorry, the initial prediction we have first. As I told you, that this is the first guess which you have put it as your initial prediction, then your first model, then your second model, and it combines all the models together. Okay. So now these are some of the formulas which may be helpful to you while doing gradient boost. Okay. So while calculating the log of odds for classification, you have to take the log of sample with outputs divided by sample with negative output. Okay, positive output upon negative output, and you have to take the log. Okay, in this way you can compute log of odds. Then while converting these log of odds to the probability using the logistic function, you will be doing e to the power of log of odds upon 1 plus e to the power log of odds. Okay. Like this way, you will be converting your log of odds to the probability using logistic function. Okay, this will be helpful to you. Now, there comes the formula for transformation. Okay, like this is the formula, the most commonly used formula. There are other formulas also. Okay, other things also. You can do transformation on yourself also if you want to put some transformation at your end. But this is the most commonly used formula. What we have to do, we have to take the summation of all the residuals and divide with the summation of previous probability into 1 minus previous probability. Okay, like this way you can do transformation in gradient boost classification. Okay, now this formula I have already told you. What we have to do is we have to add all the outputs together by multiplying them with alpha, which is our learning rate. Okay, you can set this alpha also with the help of hyperparameter tuning. Okay, now what I have done is, now this is basically this is you can see that this formula h0 of x alpha 1 x1. Okay, so in more simplified way you can write this formula as summation of alpha I hi of x, where I ranges from 1 to n. Okay, like this way it becomes more simplified. Okay, now see this figure we have. Okay, uh, um, in this figure you can easily see that we have residuals and tree predictions. Okay, this on the left side we have the prediction of a single tree. Each week learner we have a single trees prediction we have on left hand side, and on the right hand side we have the ensemble predictions. That is nothing but adding these models together. Okay, so in the very first row, you can see that we have the output for a first model. Okay, and on the right hand side, it does not change because it is our first model only. Okay, but as soon as you will be seeing the second row, okay, as soon as you will be seeing the second row, you will be you will come to know what is the change. Okay, see that the output of the second model, and now you see the output on the right hand side. You see the output combined, the combined output of the first model and the second model. Okay, we are on the right side and we are performing better. Okay, now in the third model you can see, when we have combined all in the third row on the right hand side, you can see we have combined all the outputs together. So how good our model is performing. Okay, it is the output of the one moon's data set, okay, which I have taken to show you how it works. Okay, one more thing is that as soon as you will be computing the residuals after making each week learner, you will be seeing that these residuals, they are becoming lesser and lesser. Okay, as you can see in the on your first model, you have got huge amount of residuals, but as soon as you move towards your second model, then third model, they will become more and more smaller. Okay, uh, now now we will talk about the various advantages of the gradient boost. Okay, as I told you, as I have shown you in the figure also, I have told you about the working also. You will be seeing that the predictive accuracy of the gradient boost, it cannot be termed. Okay, it will perform really very much better. Okay, now in this gradient boost you will have lots of flexibility. Okay, as you can optimize on different loss functions and provide several hyperparameter tuning options, so it is very much flexible. Okay, no data pre-processing is required. Okay, even if your data has a missing value somewhere or something like that. Okay, if your data is categorical or numerical values, it works well with all these kind of data. Okay, uh, and also a benefit of gradient boosting framework is that a new boosting algorithm, it does not have to be derived for each loss function, okay, that may want to be used. Instead, it is a generic framework. As I told you that you can use any loss function that is differentiable. You can use it by your own, okay, or you can use the loss function which is already there. Okay, so just one thing you have to keep in mind, that it should be differentiable. Only that thing you have to keep in mind. Otherwise, any loss function you can use. You can even define your own loss function. Okay. Now we will see some of the disadvantages of the gradient boost. Okay. You should keep in mind these disadvantages, because in XGBoost we will be discussing more. Uh, as you can see that you can build a huge amount of trees. Okay, gradient boost build huge amount of trees. Okay, more than even more than 1,000 trees. Okay, so now this thing creates a problem with your memory. Okay, your memory becomes exhaustive. Okay, while building more and more trees, your memory is really becoming very exhaustive, and even it's taking too much time. Okay, I have one figure with me in the XUs. I will show you that figure, that gradient boost takes really a hell amount of time in computing the results. Okay, another thing, you can see that I have told you that it tends to overfit the data. Okay, that we have already dealt with, that it tries to overfit your data set. Okay, and it also overemphasize your outliers. Okay, if you have outliers in your data set, then you should pre-process your data set first, and remove those outliers. Okay, next thing is that the high flexibility results in many parameters that interact and influence heavily the behavior of the approach, that such as the number of iterations, the depth regularization parameters, that requires really a large grid tuning. Okay, grid search tuning. Now they are less interpretive in nature, although this is easily addressed with various tools. Okay. Now we will see some of the practical applications of gradient boost. Okay, so gradient boost is widely used in real world also. In neurobotics, gradient boost is a useful practical tool for predictive tasks and consistently provides higher accuracy results compared to conventional single strong machine learning models. Okay, in neurobotics, you can use it in EMG and EEG sensor readings. Okay, to convert human movement tracking and activity recognition. Okay, also gradient boost is used in the field learning to rank. Okay, many commercial web search engines like Yahoo and Yandex, they use the variants of gradient boost in the machine learning rank engines. Okay, it is really very important uh, in learning to rank. Now it's also used in high energy physics in data analysis. Okay, at the large hardened corridor, variants of gradient boosting deep neural networks were classified and reproducing the results of non machine learning methods on analysis on data sets, and used to discover Higgs boson. Okay, this Higgs boson, let me tell you that it is basically an elementary particle in the standard model of particle physics, which is produced by the quantum excitation of the Higgs field. Okay, one of the fields in the practical physics story. Okay, this particular is related to physics, and it's really very important in high energy physics in data analysis. These are some of the practical applications of gradient boost. Okay, now this is basically the comparison between AdaBoost and Gradient Boost. As I think someone, I think like Sunil is asking about this. Uh, okay, yes, Sunil is asking about what is the difference. Okay, so Sunil, now as we have covered the Gradient Boost also, okay, now you can see in AdaBoost what we have done. Uh, Yes. Okay. Now, Sunil, I know. I think that you can classify them. Okay. You can differentiate them. Okay. As in AdaBoost, what we have done, we have updated the weight of the previously classified misclassified sample. Okay. We increase the weight of that sample and then pass it to the next week learner. Okay, and in gradient boost what we did, we compute the residuals, and we tried to fit of features and those residuals in a decision tree, and then compute the second residuals, and like that, in the end, we add all the outputs of these trees together. Okay, so in AdaBoost, what is it? AdaBoost is more about the voting of the weights, and in Gradient Boost, it's more like adding gradient optimization. Okay, we have discussed about both these algorithms. I think that these both algorithms are clear to you. Okay, before moving towards the XGBoost, I will urge you all to write in the chat box whether these algorithms are clear to you all, or you have some doubt. Doubles update. Okay, Deepak Pamwani. Okay, Deepak Pamwani, are you asking some doubt? Okay, if you are asking some doubt, please be more clear. Mm. Okay, acha, you are differentiating them. Acha, okay, okay, okay. We try to minimize the error weight. Yes, yes, yes. I understood, Deepak. So, you not like we try to minimize the error weight. Okay. Normally, what we do is we generally try to compute the residuals. Okay, and try to fit on next week learner on the residuals, on those residuals. Okay, which we have computed. Okay, there is nothing like updating the weights. Okay, we have no concept of weights in Gradient Boost. Okay, Deepak Pamani, it's is it clear? We have to update the weights in other boost only. Okay, okay. So now I guess no one is having any doubt. So now let's move on towards our next boosting algorithm, that is XG boost, also known as extreme gradient boosting. Okay, now let me first tell you that XGBoost was introduced because gradient boost computes the output at very slow rate. Okay, as we have seen in the disadvantages of gradient boosting. Okay, this is the main reason why invented the extreme gradient boosting. Okay, because it computes the output at very slow rate, as there is sequential analysis of the data set, and it takes a longer time, large amount of memory, and all that things. Okay, so that's why we have introduced the XG boost, and let me tell you, it is the fastest boosting algorithm. Okay, please keep your mics off if anyone is unmuted. Okay, please keep your mics off. So we haven't. The main reason behind the invention of XGBoost is that the gradient boost computes the output at very slow rate and takes a huge amount of memory and all that reasons. Okay, let me tell you that this XGBoost or extreme gradient boosting algorithm. It's okay, Sunil. Uh, uh, the main driving force behind the algorithms that won massive ML competitions is extreme gradient boost or XGBoost. Okay, be it Kaggle or anywhere else, the Netflix recommendation competition also, and various competitions. The main driving force behind the algorithms is XGBoost only. It is really very good and very fast algorithm. See, this was the figure which I was talking to you about. uh, as you can see that in this figure we have the performance comparison using sklearn's make classification dataset. Okay, on the left hand side we have AUROC, the measure of the prediction power, and on the right hand side we have training time. Okay, as you can see the comparison between different algorithms. Okay, in XGBoost it is 96.62% accurate in just and the training time which is required is 24 seconds. Okay, in gradient boost it is 96 0.61 percent correct, but the training time, as you can see, the difference of the training time between XGBoost and the gradient boost. Okay, it takes 2069 seconds to train gradient boost. In random forest, it is again 95.42% correct. It is its training time is 4 to 4 seconds, and logic regression is 17 seconds. Okay, so now you can easily make a difference between the training time of XGBoost and gradient boost. That's why we have XGBoost with us right now. Okay, so this is the evolution of the XGBoost algorithm from decision trees. Okay, starting from decision trees, then bagging, random forest, boosting, then gradient boosting, and at last we have got the optimized gradient boosting algorithm. Okay, this is how the XGBoost has evolved itself. Okay, from all these. Okay, now let's discuss about what are the steps in XGBoost. Okay, so let me tell you that as this is also a gradient boosting algorithm, so the initial steps for the XGBoost is same as the gradient boosting algorithm. Okay, it is same. At the first step, we have to make the initial prediction. Okay, this initial prediction is our first guess. Okay, this is the initial leaf. Okay, uh, um, so this can be anything regardless, using whether you are using classification or regression. You can do anything. Okay, in regression you will take the average of the values, and classification similarly you can take the log of odds, as we have discussed earlier also. Okay, after this what it does, similar way in gradient boosting, it tries to calculate the residuals and subtract those residuals, try to gain the residuals by how it will compute the residuals by subtracting the predicted value from the observed value. Okay, these initial steps are the same. Then in the step 2, what you will be doing is, once you have calculated the residuals, you will be making a tree based on these features and residuals. Okay, so always one thing you have to remember, that in XGBoost, whenever you are constructing a decision tree, it should always be a binary classifier. By binary classifier, what I mean is that it should always have two leaf nodes only. Okay, the levels can be any. Okay, you can take any level. Okay, but the leaf nodes, this should only be two leaf nodes. Okay, this what I mean by binary classifier. Now here comes the magic of the XGBoost. Okay, now the previous steps was same like gradient boosting, what we had done there, making initial prediction, computing residuals, fitting those to the decision trees. Now what XGBoost does, it will calculate, when you have built a tree, it will calculate the similarity weight for each of the leaves and the root nodes. Okay, how it will calculate it, both for classification and regression problems, you have different formulas for calculating the similarity weight. Okay, for classification, you have summation of residual square upon summation of probability into 1 minus probability plus this lambda. Okay, for regression, you have summation of residuals upon number of residual plus lambda. Okay, this lambda, it can be set with the help of hyperparameter tuning again. Okay, it calculates the similarity weight. Okay, so why XGBoost calculate the similarity weight? Okay, so let me tell you that XGBoost calculate the similarity weight in order to decide whether the feature, okay, as we have number of features with us. Okay, so it will decide that yes, this feature is the best feature among all, this is the best to split. Okay, this feature is the best record to split. Okay, so it will be deciding whether the feature it is taking as the root node is the best record to split or not. Okay, that's why it's calculating the similarity weight, and that's why XGBoost uh, is better than gradient boost. Okay, now after calculating the similarity weight, okay, what it does, it calculates the gain. Okay, how it's calculate the gain? It takes the similarity weight of the right leaf and add it with the similarity weight of the left leaf, and subtract the similarity weight of root from the addition of these both leaves. Okay, you can see the formula, okay, here. uh, it will select a tree with the maximum gain, and it splits from that record only. Okay, this is how it calculates the gain. Okay, whichever record is giving the maximum gain, it go with that record. Okay, so after selecting the best split, XGBoost will go for the next feature. Okay, similarly, okay, as it has chosen the first feature, let's say if it has chosen the first feature for the root node, now it might choose the third feature or the fourth feature for the next split. Okay, like this way XGBoost will go for the next feature, and it repeats the same process of calculating the similarity weight and then the gain of the tree and selecting the tree with the maximum gain. Okay, this process goes on and on, and at last, okay, first let me tell you that it will select different features each time. Okay, and at last the addition of similarly we have done in gradient boosting, similar way the addition of all the trees are put together in order to get the final output. Okay, so I think these all things are clear to you all. This is the mathematics behind the XGBoost. Okay, it is same like gradient boost, just with a little difference of calculating the similarity weight and the gain and selecting the best feature for the split. Okay, that's why it's more good than gradient boosting. Okay, we have one more concept in XGBoost. Okay, that is known as post pruning. Okay, now what is this post pruning? Let me tell you that whether XGBoost will go for further splitting or not, it is decided by the concept of known as post pruning. Okay, you can see that it can go up to n number of splits. Okay, so by selecting different feature each time. Okay, so when will it had to stop? Okay, that is decided by post pruning. Okay, in classification, this can be calculated with the help of a cover value. Okay, what is this cover value? Let me take you to this slide. In classification, what we have done, summation of residual square upon summation of probability into 1 minus probability plus lambda. So this denominator which we have, this probability into 1 minus probability, we take this as the cover value. Okay, so when taking this as a cover value, now we will see that if the gain which we are getting, okay, so we are calculating the gain, so the gain which we are getting, is it less than this cover value? If it is less than this cover value, then we will cut the branch. Okay, we will not go further for splitting. Okay, but if this gain, it is greater than the cover value, we will go on further splitting. Okay, this is very easy thing in XGBoost. Okay, uh, in regression, what we do, we have a one parameter known as gamma. Okay, we can set this gamma with the help of hyperparameter tuning. Okay, uh, if the value of gain minus gamma is negative value, we can post prune the tree. Okay, we can cut the tree, that is we can cut that particular tree. And if we have a positive value, we should not cut the tree. Okay, so it is very simple. You just take the value of the gamma, you subtract it from the gain. If you are getting a negative value, you just postpone the tree. Okay, that is you just cut the tree. If you are getting a positive value, you should not cut the tree, you should go for further splitting. Okay, I told you that this gamma, it is a hyperparameter, and you should use this only when the tree is overfitting. Okay, if there is anything like overfitting happening with your data set, then only you should use this. Otherwise, This gamma, it is a default value which is set by the xg boost. Okay, now we will see certain advantages of the gradient boost. Okay, we have various advantages for the gradient boost. It is parallelized tree building, tree pruning using depth first approach, cache awareness, and out of core computing. Okay, as you have seen that in gradient boost, we our memory gets exhaustive when we build large number of trees. Okay, so it's very good with cache awareness and out of core computing. Then we have regularization for avoiding overfitting. As I have told you in the previous slide, only when it's overfitting, you set that gamma value. It's efficient with handling the missing of the data. Inbuilt cross validation capability. These all are the advantages of the XG boost. Okay, I have described all these advantages one by one here also. Will the slides be shared with us? Yes, yes, they will be shared in the end of this. At the end of this session, we will tell you how you can access to this content. Okay. Uh, okay, Sunil. So in XGBoost, you have built in L1, that is lesser regression and regression. If you have learned something about this about linear regression, you have seen what is regularization, what is lesser regression, what is rich regression. Okay, which prevents the model from overfitting. That is why XGBoost is called regularized form of GBM. Okay, then you have parallel processing. XGBoost utilizes the power of parallel processing, that it takes into account multiple CPU cores to execute the model. Okay, that's why it's much faster than GBM. Okay, it uses multiple CPU cores to execute the model. Okay, it is very good at handling the missing values. Okay, if your data has missing values, so when the XGBoost encounters a missing value at a node, it tries both the left and right hand split and learns the way, leading to higher loss for each node. Okay, it then does the same way working on the testing data also. Then for cross validation, XGBoost allows the user to run a cross validation on each iteration of boosting process. Okay, you have learned about cross validation before also. So it allows you to run this cross validation at each iteration of boosting process, and thus it is very easy to get the exact optimum number of boosting iterations in a single run. This is unlike GBM where we have to run a grid search, or only a limited values can be tested. Okay, now effective tree pruning. Okay, we have discussed about tree pruning already, so it is just like that only. So these are certain disadvantages of gradient boost. Okay, like any other boosting method, as we have discussed just now, that these boosting algorithms, they are sensitive to outliers. XGBoost is also sensitive to outliers. Okay, unlike GBM, in XGBoost, one has to manually create dummy variable encoding for categorical features before feeding them into models. Okay, you have to make the dummy variables encoding for categorical features. Okay, you cannot directly feed them to your model. Okay, if one thing is that it has black box nature. Okay, if you need the effective sizes of XGBoost, it won't give them to you. Okay, though in some algorithms like AdaBoost, they can give it to you, but in XGBoost it is a black box nature. It definitely not gives you the effective sizes. Okay, you had to derive and program that part yourself only. Okay, it overfits the model if model is not stopped too early. Okay, this is also very important, that if you don't stop your model too early, it overfits your model. Okay, uh, with the help of tree pruning, we can do that easily. We had discussed that earlier also. Okay, now let's see about the practical applications of XGBoost. Okay, we have this one thing, application of XGBoost algorithm in fingerprint localization task. Okay, this research paper, it was published in Computer Information System and Industrial Management at the 16th IFIPTC 8 International Conference. Okay, These three people, that are the Markin, Luckner, and Bartosz Topolsky and Meglenda Mezrek, they published this research paper. Okay. It is also a very good research paper. It is available online. If you have time, just go through this. You will understand more about XGBoost. Okay. What they have done, they have an indoor positioning system, issues regression and classification challenges in the form of horizontal localization floor detection. Okay, if you are standing on let's say third floor. Okay, so if you have built some system to detect your floor. Okay, so how it will be trained. Okay, so they have trained that with the help of the XGBoost. Okay, so they propose this to apply XGBoost algorithm for both the tasks. Okay, the algorithm, it uses the vectors of received signal sense from Wi-Fi access point to map the obtained fingerprints into horizontal coordinates and the current floor number. Okay, then the second application is also very good, the predicting sales volume using XGBoost. Okay, uh, one person, Omar Farak Eslantas. Okay, he has written one article. It is available online. You can search this. Okay, it is one of the in which he has shown that the XGBoost is one of the most efficient ways for forecasting your sales data with the help of XGBoost library. Okay, so these are some of the practical applications of XGBoost. Okay, so with this, we have come to the end of a today's session about the boosting algorithms. If you have any questions, any doubts, you can ask me in the chat box. If it is clear to all, please write in the chat box that also. Can you repeat regularization? It's a regularization. Okay, in XGBoost. See, 1 minute. In regularization is basically a term in machine learning. Okay, we have different regularization like L1 regularization, L2 regularization, the lasso regression. L1 is the lasso regression and L2 is the ridge regularization. Okay, they are basically used to prevent the overfitting of the model. Okay, so in XGBoost, these regulations, they are inbuilt. Okay, they are inbuilt regulations. You don't have to do anything with these regulations. In XGBoost, you automatically get these regulations. Okay, uh, if you have learnt about linear regression or something, you know about these regularizations, I guess. uh, they are concept in machine learning. Okay, Harsh Maurya. Okay, okay. They are inbuilt in XGBoost. You don't have to do anything. Understood. Okay. Thank you, Sunil. Anyone having any other doubt? You can write in the chat box. If you are not having any doubt, then we can go to wrap up this session. Okay, okay, Frederick. Okay, Sanant Lakshma. Okay, Harsh Maurya. Okay. So now, I would request you all to please provide your feedback on any of the posts on whether on LinkedIn or Facebook or Instagram. It really help us in improving our sessions and our contents. So you can provide your feedback. We have already shared the post links with you all. Okay, in the chat box. Please provide your feedback, and we will in order to get the certificates also. Okay, Sunil, thank you so
Right.
much. If you
Thank you so much, Garvit. It's been a great session, and I'm sure It will help a lot many people if they have been focused throughout the session. If you have been into data science for quite some time, you will know the importance of boosting algorithms, and they come a lot handy when you have sophisticated data and you want to handle the real-time data. So if someone has doubt, please feel free to ask Garvit. He's here. And if you get any doubt after the session, maybe please feel free to leave it on either of the social media platforms, maybe LinkedIn, Facebook, Instagram, whatever you are comfortable with, or wherever you are present. And if you have not created profile on either of these social media platforms, then I'll highly request at least to be present on the LinkedIn. It will help you a lot in your corporate career. It will help you a lot as a students as well. All right. And we have shared the feedback links already. So what we do is we keep the feedback public instead of collecting the feedbacks through some Google form. Reason being, it will help other people also know how the sessions have been. It will help them decide their mind for the sessions, whether they should be attending the session or should not attend the session. And it helps us as well, to reach more and more number of people, so we can take this initiative to the maximum number of people. So do provide your valuable feedback. Nobody is obliged to write only good. If you felt no session did not do justice to the time, or did not do justice to the expectations that you had from the session, please do write that also. So you have to write one word. Let's say if you felt good about the session, do write good. If you felt extremely good, then write great, something like this. Okay, but the feedback has to be only in one word. However, you are allowed to give the elaborative feedback on the poster of this live session. If you go to either of these live sessions, either of these social media platforms like LinkedIn, Facebook, Instagram, you will see that there is a poster of this live session, uh, where the speaker names are mentioned, date is mentioned, joining registration link is mentioned. Please do provide your elaborative feedback on that. So with that note, anybody else or anyone has doubt? And I believe someone was talking about the content. So all the content will be uploaded on the our website. So if somebody does not know what is the website link, I'll post it once again. I guess some of you been asking about the slides, material, everything. So everything would be available on the website. Do not worry about it. Okay, it's all for you. Please learn. Please explore as much as you can. And yeah, share words in your data science community, in your friend circle. All right. So I have pasted the links. I have pasted the website link as well, and the different social media platform links as well. And I guess Harsh was asking about the regularization, if I'm not wrong. Yeah, regularization. Okay, all right. So Harsh, this is the different. I mean, not the different topic, but this is the topic that has to be handled separately. What Gavit has done, he has brought regularization in notice that how this is connected to the XGBoost. But you can read on the regularization what are these and importance of these. This is very important topic. So I'll highly suggest you to go back and search on the Google what is regularization. And when we conduct live sessions in future, we'll be talking about the regularization, maybe in the future live sessions maybe. Okay, but this is very important topic. Please make sure that you learn about it. All right, please confirm Harsh in the chat window if you get my message. Harsh, could you please confirm in the chat window? Yes. All right. All right. Thank you so much. Please do learn about this topic. It's very important. Anything else that you guys would like to ask to me or to Gavit maybe before we wrap up the session? Any doubt? What's the topic on the next session? So whatever topic would be, it will be up on the social media. So please stay tuned to that, Sunil. Anyone else? If you guys have no doubt, please say no in the chat window so we know, okay, we are good to wind up the call. And please make sure that you guys submit your mark your attendance on the social media platforms. Attendance post is already up. So it will help us, sharing the participation certificate. All right, Santana says no. Cedric says no. Could others also confirm so we can wind up the call? Few more responses maybe. All right. So I guess then I take this as a, there are no doubts, and we are good to wind up the calls. If at all you get any doubts, we are all here. Please, reach out to us for whatever doubt you get with regards to data science or about the live session or maybe the content or any general query maybe. All right. Chalo, bye bye. Take care. Happy weekends. Have a good evening ahead. Bye bye all. And thank you so much, Gavit, once again.
Welcome, sir. Thank you, everyone.